Caitlyn.
Caitlyn, we're saying hi to you. We miss you.
Hi.
You see the pretty one, the aunt. You see the ugly one, Micah. And okay, there you are. We miss you. Yep. We hope you're having fun. We can't wait to see you soon. Okay. Yep. Let us be. Get out of here, guys. Okay. Let me be.
Okay.
All right. So yeah. So we're doing this. Whoa. And the water went everywhere. They're gonna have to clean that up. Very good. So we're gonna look at this problem. We're gonna approach it as sum of vectors, and then we're gonna do a different one. We're just gonna use the law of cosines here. Hey, Kiara, can you give me my calculator, please? So if you consider the sum of vectors, what's happening here is we have this this car that's traveling north like that, and it arrives at a location of this 0, 40. So that's the vector location. But then it heads off in this direction, and we know that that angle there is 40. We don't know the component vector piece, but what they're ultimately wondering is this is the new vector that's formed, that dotted line, and we're looking for theta, or that angle right there. So I'm going to break this up into two parts, and the first one is very easy. We look at the first vector, which is going to have a location of 0, 40. Okay. I'm going to look at the next vector here, okay? And the next vector is going to be this way. I'm sorry, 0, 40, 32. It's 32 kilometers. Sorry, I got my numbers mixed up there. So 32 kilometers. So that coordinate 0, 32. Sorry about that. But this angle here is 40 degrees as it kind of tails off to the side. And you know that the distance is 46. If you consider that, you just have a right triangle that we're trying to solve in that situation. If I draw out this right triangle a little bit larger, you know that this angle here is 40 degrees because it's 40 degrees west of north. So if this is my north angle and this is west, 40 degrees we turn to the west of north. That's what that means. I actually take my kids through 3 days of just solid work on bearings so they can understand these type of things. So maybe that was glossed over for you. But then this distance is 46. And so I'm going to call this x, I'm going to call this y, meaning this is the horizontal component and this is the vertical component of the vector. And we're looking for this triangle. What we have is we have an opposite side right here, and then we have this hypotenuse. And what involves the opposite and the hypotenuse? The opposite and the hypotenuse in that situation is going to be sine. And so what you would have here is the sine of 40 degrees is equal to x over 46. Multiply both sides by 46. 46 sine of 40 is equal to x. I take out my calculator, turn it on, clear mode, make sure I'm working in degrees, which I am. And I've got 46 sine of 40, and I get 29.57. And then if you look for this component right here, this guy, you can see that you're looking for the adjacent and the hypotenuse. Adjacent hypotenuse, that's going to be cosine. So cosine of 40 is equal to, again, adjacent, which is y, divided by 46. Multiply by both sides by 46, we get 46 cosine of 40. And you get 35.24. So y is 35.24. So what's happening here is this car, again, it has a vector right here that we said of 0, 32. And then from that, it takes on another vector form. And this other vector has a component form of 29.57. And then the vertical part was 35.24. Okay? And if we add those together, it gives us 29.57 and then 35.24 plus 32. Well, that's going to be, 67.24. So that's this coordinate right there. Except I'm going to give it a negative value. Well, we don't have to. We'll just talk about it. We got 29.57 right there, and then a 67.24. So that's the x value. That's the y value. Sometimes they say that's the a value. That's the b value. So now that we have that, what we want to do is we want to find this angle. That angle right there. And the way that we find that angle is we set up the argument of tangent. So again, if you just consider that angle, this side right here is 29.57. That's the horizontal part. And this vertical part is 67.24. So you can set up the tangent of theta is equal to 29.57 divided by 67.24. Now you're just going to inverse tangent that guy. So tangent inverse, and we've got 29.57, and we're going to divide that by 67.24, and we get 23.74 degrees. So that means 23.74 degrees west of north. And so that's that angle. So 23.74 degrees west of north. That should, probably be the way that they would want the answer. And my guess is that that's how they want you to do the problem. Okay, that's my guess of how they want you to do the problem. Now, another way of doing it. This is the way I would. So if I would approach a problem blind, you just give it to me. I love the law of cosines approach. And here's why it's so cool. It involves less steps. And I love the law of cosines. Here we go, 40 here. Here we go, 46 right here. And we know that this angle right here is 40 degrees. I'm sorry, I keep saying that's 40. It's not 40, it's 32. Sorry about that. So that's our picture. Well, if that's 40, this is 140 degrees. You see the triangle I've got right there. I've got an angle, a side, a side, an angle, and a side. When you have a side and angle of a side in that situation, you could set up the law of cosines. Namely, if I call that C right there, you would have C squared is equal to 32 squared plus 46 squared minus 2 times 32 times 46 times a cosine of 140. I'm going to type all that into my calculator. 32 squared plus 46 squared minus 2 times 32 times 46 times a cosine of 140. And I get that. I'm going to square root that guy. And that's going to give me 73.45. That means this distance is 73.45. Now I could do something very simple. Set up the law of sines. Sine of 140 divided by 73.45, because I now have the opposite side, is equal to, call that theta, sine of theta divided by the opposite side is in fact 46. So 46 sine of 140 divided by 73.45 is equal to sine of theta. Let's see what that 46 times the sine of 140 divided by 73.45. I get that. And I inverse sine that answer. I inverse sine that answer, and I get 23.74. So 23.74 degrees west of north. So let's check that with my previous work. We tried it 2 different ways. Hey, look at that. In both situations, I got 23.74 degrees west of north. So that's just one last piece, is as you work to be a really, really excellent mathematician, it's not just finding one way to do it, it's finding multiple ways to do it. And that way you can always check and verify your answer. Now, This is the first time I've worked it out. I've worked it out two ways, law of cosines and sum of vectors. And I really think that that's the, that I'm right because of that. So I don't know how they want your answer expressed, but I will just finally say this. If they call this 0 degrees or 360 degrees, this 90 degrees, this 180 degrees, this 270 degrees, if you subtract off that 23.74, you would get 360 minus 23.74, and you get 336.26. So 336.26 is the same as that. One is a standard bearing, the other is a directional bearing. I don't know how they want your answer, but those are the things we talk about. So it's a good question. It's a tough problem. There's two approaches. My guess is that they want you to do it this way, the sum of the vectors. I sure like the law of cosines approach in that problem. So hopefully that made sense. If I went through it too quick, I'm sorry. Reach out and we can go over it together. Later, kid.